Hey folks, Ms. Gosling here. In this video, you're going to learn about free body diagrams. By the end of the video, you will be able to draw free body diagrams for objects experiencing one or more forces. So let's go ahead and get started, shall we? Let's start off by defining a free body diagram, because I'm guessing you have never seen this term before. So a free body diagram is a method of depicting all of the forces acting on an object. We use it to find the magnitude and direction of the net force acting on an object. And when I say net force, I mean total force. So that's all well and good, but how do we do this? Well, there are a few rules for drawing free body diagrams. First of all, the diagram should depict only the forces acting on one body. So, for example, if I have a table and on my table I have a pineapple, I can draw a free body diagram for the forces acting on the table, or I can draw a free body diagram for the forces acting on the pineapple, but I cannot draw a free body diagram for the forces acting on both the pineapple and the table unless I want to draw two separate free body diagrams. So that's the first rule. The second rule is that forces are depicted as arrows. So every force acting on the object I'm going to depict as an arrow. Third, those arrows are drawn to scale. So for example, if the normal force if the gravitational force on my pineapple is the same as the normal force acting on my pineapple, then those two vectors should be the exact same length. So what I just did, you can the arrows I just drew actually are very similar, or kind of lead us into point number 4. And that is that all arrows should start at a point that represents the center of mass of the body. So what that means is, rather than taking a picture of my pineapple and drawing the gravitational force coming out of the bottom of my pineapple and the normal force coming out of the top of my pineapple, what I'm going to do is I'm going to draw a dot that represents my pineapple, and I'll draw my gravitational force and normal force, both arrows being the same length since my pineapple is staying on the table. And those two arrows are both going to come out of that center of mass of the body, and they're going to both start in the same place. So that's rule number 4. Rule number 5 is that all forces are clearly labeled. So I can't just leave my gravity and normal force arrows as is. I need to label them as the gravitational force and the normal force. So these are the rules for drawing free body diagrams. So let's talk about how to go about doing this when you're given a word problem. So the first thing you want to do is draw a picture like you normally would. So if I have a pineapple sitting on a table, I'm going to start by drawing my pineapple sitting on a table. Often, your picture will be given, but not always. So sometimes you can skip step 1, sometimes you cannot. So second, you're going to decide which object you'll be drawing a free body diagram for. Draw a dot to represent this object. So if my pineapple is sitting on my table, I have to decide, am I looking at, does my problem ask me to figure out the forces on the pineapple or the forces on the table? Whichever one that is, I'm going to draw a dot for. And it's going to be, and all of my arrows are going to come out of that dot. Which brings me to number 3. I'm going to draw and label all the forces acting on that object. So for my pineapple, I drew my normal force and my gravitational force both coming out of that dot representing my pineapple. So that was a lot of information. Let's apply this to an example, shall we? A cat sits on a hat. The mass of the cat is 3 kilograms. What is the normal force of the hat on the cat? So in this problem, not only are we going to be drawing a free body diagram, we're also going to be talking about how free body diagrams can be used to figure out individual forces. So let's start by drawing a picture. Here is my hat, and here is my cat. and my cat is sitting on my hat. We are trying to, so we know that the mass of the cat is 3 kilograms. And we want to find the normal force of the hat on the cat. So what that means is that I'm going to be drawing my free body diagram for the cat rather than for the hat. So let me start by drawing my dot to represent my cat. Now, my cat has mass, so that means that I know that there is a gravitational force acting on my cat. I also know that my cat is not falling through my hat, so that means that the normal force acting on the cat must be equal to the gravitational force acting on my cat. So what that means is that the gravitational force is equal to the negative of the normal force. And that's because they are of equal magnitude and in opposite directions. So this brings us to the next piece of new information. And that is, how do we go from a mass to a force? That is actually very simple. So the force of gravity is equal to the mass of an object times its acceleration due to gravity. So on Earth, the force of gravity is equal to 9.8 times the mass of the object. So in this example, the force of gravity is going to be 9.8 times 3, or approximately 30 newtons. So what we can say is that 30 newtons is equal to, let me go ahead and go back. So 30 newtons, and that 30 newtons here is pointing down. So we know that negative 30 newtons is equal to the negative of our normal force. So what that means is that our normal force is going to be positive 30 newtons, so that it balances out my gravitational force on the cat. So there you go, guys. I started out and I drew a free body diagram using my picture of my cat. I calculated the gravitational force on my cat, and I used that to figure out the normal force on the cat by saying that the gravitational force is equal to the normal force, which I understand from my free body diagram. Okay, guys, so let's go ahead and talk takeaways. First of all, a free body diagram depicts the forces acting on one object. Second, all force vectors should emanate from one point and be clearly labeled and drawn to scale in a free body diagram. So there you have it, guys. You now know how to draw free body diagrams, and bonus, you've learned how to use them to solve simple balanced force problems. So now it's your turn to give this your best shot on your own. Best of luck and happy solving.